All right, Coach Ray back here, getting ready to factor some quadratics. Okay, just real quick on that title. Quadratics look like this. Hopefully it's reviewed from Algebra 1-2. Okay, where we have an x squared, an x term, and a constant. That's a quadratic in standard form. Okay, just so you know, quadratics are also called trinomials because there's three terms. And trinomials generally factor to be a binomial times a binomial. So 2 terms times 2 terms is what we're going to be doing here. All right, so let's start. Example 1. I'm going to start with this x squared guy. Let's just do him first. Okay. So I'm going to make a room. And in that room, the area is x squared. Do you know the dimensions of that room? Probably x times x, right? It could be x squared in 1 though. Okay, so we're guessing, but I will just tell you that most of the time if you are asked to factor, they factor nicely. Okay, so we're just going to guess x times x and assume that whoever made this problem wasn't a huge jerk. Okay, and here's what I'm going to do. I need more in my room, because remember what I'm doing is the area of the entire room is x squared plus 9x plus 20. So I definitely need more to my room here. I'm going to have additions onto my room. It's getting a little ugly, but that's fine. Okay, the other part of my room that I know is right here. Positive 20 I'm putting down there. Okay, yeah, should start looking familiar. So positive 20 I put here, and now what I'm looking for is I want the dimensions up here and over here that will give me 20. The dimensions of that room could be 5 and 4, 10 and 2, 1 and 20, correct? I always advise you to guess the 2 numbers that are closest to each other. Does it always work? No. But for someone who's been factoring for way longer than you've been alive, it works more often than it doesn't. Okay, so I'm just going to guess that the dimensions of this room are 5 and 4. Okay, so those would create positive 20 right there. All right, so now I got to check out these other parts of my room. Up here in the upper right corner, I would have x times 5. This area would be 5x. This area down here would be 4x. And now what you can see in my entire room is I have x squared, I have positive 9x, and I have positive 20, which was the original problem. Okay, remember I guessed. Had I guessed 10 and 2 for the dimensions of that 20 room, I would have been wrong. Okay, but we guessed correctly. So my room now is made up of x squared, positive 9x, positive 20. And that's what we were trying to do. So now here's what our answer looks like. What we broke this up into was up here I had x and positive 5. I'll write it like a binomial. And on the side, we had x and positive 4. I will write it like a binomial. And there's a 4-letter F word you could use to check to see if that's the same thing as the question. Foil. First, outside, inside, last. If you multiply that out, you should end up with what you started with. An easier way to check to see if that's correct is into Desmos, plug in x squared plus 9x plus 20, and then on another line, plug in x plus 5 and x plus 4. If they're the same, they should line up on top of each other. Okay? All right, example 2 is clearly harder. Yeah, right? We put some more algebra 3, 4 like numbers in here. I'm going to do the same thing now. Okay, I'm going to make my big old room. The area of this giant room needs to be 6x squared minus 23x and positive 20. So there's a couple areas I can fill out right away. This area needs to be 6x squared. This area needs to be 20. I always deal with, and now we got some negatives in there. I'm going to deal with the negatives all at the end. Okay? So I need to start guessing my dimensions. And this is what makes factoring fun or real crappy. Let's start with my 6x squared room. What are the dimensions of that room? 2x and 3x is a possibility. 6x and 1x is a possibility. I would advise to guess the numbers that are closest to each other. So I'm going to guess 3x and 2x. I don't know if it's right. I might have to go back to that. But that's where I'm going to start. Now I'm going to guess the dimensions of that other room. I'm going to guess 5 and 4. And I got to check. Factoring is about guessing and checking. So these two rooms, 4 and 3x, this room would be 12x. Over here, this room would be 10x. 12x and 10x, and ignore signs for now, cannot combine to give you 23x. Close, we can make 22, but not 23x. So I've got to change something. I'm going to try switching my 5 and my 4. That will give me some different stuff. If I put a 5 here and a 4 here, the area of these rooms is going to change. This one will now be 15x. This one will now be 8x. Can I make 23x out of 18x and 5x? Yes. But it's got to be negative 23x, so watch what I do. Here's how I mess with my signs. I need negative 15x and negative 8x. Now they're going to combine to give me negative 23x. Okay, but now what I got to change is, to get negative 15x in here, I did 3x times 5x. I'm going to make my constant negative. So now 3x times negative 5 gives me my negative 15x. Okay, same thing over here. I needed negative 8x. I'm going to do 2x times negative 4, making my constant negative. So now I have negative 8x in here. Now my giant room is filled with 6x squared, good. Negative 23x, good. Positive 20, beautiful, I'm done. Okay, so my answer is, and it doesn't matter what order I write these in. I can write 2x minus 5 first, or 3x minus 4. So I'll put this 2x and negative 5 here, and 3x and negative 4 here. And I have just broken down that room into those dimensions where if you multiplied them back together, you would end up with 6x squared minus 23x plus 20. Questions? All right, I'm going to do the last example, and then if we have time at the end, I can answer questions there. Last example is about as hard as I can make a problem. Notice the numbers are big. That sucks. Notice there's a negative in front. That's weird. Okay, but there is something that if you recognize from the jump, you're like, it's way easier. Does anybody recognize?
8.
What about 8? They're not all divisible by 8. I don't think 4 either. 4 will go to 42. But they are all even, yes? If you see that they're all even, you know that a 2 can go into each, which means we've got greatest common factor. Yay. Okay, can I take an x out of everything?
No.
No, because the last one doesn't have an x. All right, I'm going to start with this. I'm going to start with, I'm going to take negative 2 out. If I take negative 2 out, that'll fix that weirdness of my front term being negative, which we haven't dealt with. Okay, so now I'm going to start doing my opposite distributive property. Negative 2 times 4 will give me that negative 8, and I need both x squareds there. So negative 2 times 4x squared would give me that negative 8x squared. Okay, now to get positive 42x, I think I need to do negative 2 times negative 21x. That'll make it positive. And to get positive 36, I need to do negative 2 times negative 18 to get positive 36. So that's just my backwards distributive property that we did in the GCF notes. All right, now I'm going to leave my negative 2 out there and do my area model for just this 4x squared minus 21x stuff. All right, so I know that this top box has to have an area of 4x squared. I know this bottom corner needs an area of negative 18. I can start guessing. Okay. If I guess for 4x squared, I recommend guessing 2x and 2x. What would I recommend guessing for my 18 room? 6 and 3. Okay, I'm going to save signs for the end. Okay, so just check these other two boxes. This box would be 6x. This box would be 12x. And look at the sequence. 6x and 12x make negative 21. No. Would it help to switch my 6 and 3? No, because then I'm just multiplying both by 2 anyway. So let me try 9 and 2. Okay, this box is now going to be 18x. This box is now going to be 4x. Oh, close. I can get 22, not 21. Okay, I'm going to change gears a little bit, and I'm going to switch my 2x and my 2x. I think that might be the problem. Okay, if I make this 4x and this 1x, now I'm going to go back to guessing my 6 and my 3. Let's see what we got. This room will be 3x. This room will be 24x. I can make negative 21 out of that. make my 24x negative, make my 3x positive. Now if I combine those, I would get negative 21x, yes? Okay, I need to fix stuff on the outside. 4x times negative 6 now will give me negative 24x. X times positive 3 will give me positive 3x. And I did it. My giant room now has 4x squared minus 21x minus 18 in it. And these outsides are what multiplied together to get that. 4x plus 3 times x minus 6. Boom! Factoring quadratics. That's it.